Hey folks, so in this video, I want to introduce the idea of microkernels. So yet another operating system architecture. So the idea is this. We want to separate the very base functionality of an operating system from everything else. We want to have the smallest possible kernel possible, i.e. a microkernel. So let's look at the diagram, right? The diagram has this thing called microkernel right over here. So this is a very, very simple system. Really all it's doing is supporting a plugin architecture, right? So I can add components to it. So it has a way to communicate with different things I add to it, and then it has a way to do message passing, to basically take a message from one plugin or one component and move it to another plugin, right? So I have a way to move things around. And in order to support this plugin architecture, I do need to have a few things. I need to have, for example, basically resource management, right? So I need to be able to give memory, right, to load up a module, right, or give it CPU time so it can run. But overall, I'm not doing a whole lot of things, right? I'm not having in my kernel, for example, the ability to manipulate a file system. I don't care about that, right? What I care about is supporting messages, supporting plugins, supporting resource allocation. Those are three things that I really care about in terms of this microkernel. My hope is that I can have the very smallest kernel possible. Why might I want to do that? Why might having a small kernel be a good idea? Take 1 second and think about it. So there's two reasons that I can think of off the top of my head. The first of is performance, right? If our kernel is smaller, it won't, it doesn't, there's simply not as much things to do, right? Obviously it's going to be more performant if you don't have to, call a million different functions to get somewhere, right? If it's very small. The other thing is that basically it's something that's easier, it's easier to maintain, it's something that's easier to make more reliable, right? So if I have a kernel that's only 1,000 lines, I can probably go through that whole thing in a lot of detail and show that it's, correct, that there's no bugs in it, right? It's much harder to troubleshoot a system of 1,000,000 lines than a system of 1,000 lines, right? So it's going to be easier to make this a very sound system. All right, so this is our basic idea of a microkernel as well as our motivation for it. So you can see here, right, we have our microkernel, right? We have basically our plugin set up, right? These are plugins over here, right? So this is a plugin. Our microkernel has those three plugins, right? You can see it's responsible for communication, for managing resources, and obviously, right, for supporting those plugins themselves. And so if I want to do things, right, for example, manipulate a file, I'll need to actually add a plugin to this kernel, right? So over here, I have this file system plugin. So the file system, right, plugs into this microkernel. All of a sudden, the microkernel has the ability to manipulate the file system, right? And so I can add in all sorts of things, right? So if I have a printer, I can add in a device driver here, a mouse, a keyboard, whatever. I add plugins for whatever piece of functionality I want to add to my system. And whenever I add a plugin to my microkernel, it's going to make that functionality available to the other plugins that are already there, right? So eventually, right, I've started the file system, I started the mouse, I started the keyboard, the monitor. Only then will I be able to add in a plugin for user application, right? Or some sort of application period, right? The application will go and basically send messages to other things, right? So I go to run this program, it wants to load a file from disk, it's going to go and talk to the plugin that supports the file system, right? So I have this message being sent from the user program to basically another module. And so that, right, is being done via message passing, right? And so the idea, right, is I'm basically allowed to incrementally add functionality to my operating system, and then when I add my programs, whatever they need, right, will happen to be there, right, and they can go ask for it. Right, and so in this diagram, I guess we can kind of continue along, right? So I have, a file system, right? Maybe from my file system, I go and I talk to the hard drive, right? So I need to use the device driver, something like that. All right. So this is kind of our idea of a microkernel, right? Keep the minimal in that kernel over here, right? And then add all the other bits of functionality you possibly want as some sort of a plugin later on. Okay. So let's see here. And in our diagram, we have hardware as well, right? So obviously my microkernel needs to, for these pieces of functionality over here, right, it needs to interact with the hardware. This stuff over here will need to interact with the hardware as well. Okay, this is our basic design. So what are the pros to this? Well, we already mentioned some of them, right? It's going to be, it may be quick, right, depending on how these message passing things are set up. It's definitely going to be something that's going to be very reliable, right? There's not going to be as many bugs as with a smaller code base. For cons, are not as serious. Generally, it's going to be more concerns about doing the design, right? Finding, what are the basic plugins that are out there. Sometimes, right, there can be issues with kind of deciding, what should have what responsibilities. In general, though, microkernels are actually pretty good. A lot of times people will use these because they are decently fast, right? They are, reliable. They are easy to maintain. It's just some design time that's kind of the drawback to figure out, how should I divide up my system? All right. So that's all I got for microkernels. In the next video, I'll talk about modules, which is kind of another approach to doing kernel architecture.